Hello and welcome to Maths with Jacob. This lesson will focus on differentiation, part 1. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. Simple slopes or gradients. We have seen many examples in our coordinate geometry videos relating to the slope or gradient of straight lines. By the very nature of a straight line, the gradient is constant. The slope of the line y equals 2x plus 2 is 2. It is the same at any point on the line. We saw earlier that slope was rise over run. That is, the vertical rise over horizontal run, and that's constant. In addition, we remember that the slope was y2 minus y1 over x2 minus x1. That is, the difference of the y values over the difference of the x values when you have 2 points. And that's constant. So, whichever way we look at it, the slope of a straight line is constant. However, there are many graphs where the slope is not constant. It varies as we move along the curve. Such curves are circles, parabolas, cubics, exponential graphs, and many others. Differentiation. The process of differentiation is a very powerful mathematical tool which allows us to calculate the gradient of curves at any point. Some necessary requirements. Most curves allow us to find their slopes because they are smooth and continuous. That is, they're not broken. They continue along smoothly with no gaps. And secondly, we can find the gradient if it exists at a given point. So it must be possible for that gradient to exist. The concept of limits. The concept of limits is closely linked to differentiation. It helps us to understand the basic principles behind differentiation. Let's look at some examples here. I'll say this through for you just to help you to understand what we're getting at. We're asking here for the limit as x approaches 2 of x plus 6. So, we can, as x gets closer and closer to 2, we can substitute 2 into this expression here. So that gives us 2 plus 6, so that gives us 8. So the limit of x plus 6 as x approaches 2 is 8. The limit of x squared plus 4 as x approaches 3. Now, as x approaches 3, we can substitute 3 into this expression. So that's 3 squared plus 4, which is 13. So the limit of x squared plus 4 as x approaches 3 is 13. The limit of 5x plus 6 plus h as h approaches 0 is 5x plus 6 plus 0, which is 5x plus 6. So in general, the limit of function x as x approaches a is function a. As x gets closer and closer to a, we can substitute a into the equation. Tricky examples of limits. In many previous videos we mentioned that we are not allowed to divide by 0. Having 0 as a denominator is not defined. Let us use some examples to see how we can overcome this dilemma when dealing with limits. So the first example, find the limit of x squared minus 4 over x minus 2 as x approaches 2. Now see here in this denominator, as x approaches 2 we have 2 minus 2 is 0, and that's not allowed. So here's how we overcome it. We factorise the numerator. That gives us that over that. Notice here we have x minus 2 and x minus 2. We just cancel those two out. And that leaves us with the limit of x plus 2 as x approaches 2 is 2 plus 2, which gives us 4. Example 2. The limit of x squared minus x minus 12 over x squared plus x minus 20 as x approaches 4. Let us factorise the numerator and the denominator, and this is what we get here. And we notice that we have a denominator here of x minus 4, the same with the numerator, so we cancel those two out. So the limit as x approaches 4 of x plus 3 over x plus 5. So when we cancel those two out, that's what we have here. So now, as x approaches 4, we can substitute 4 into this expression. So that gives us 4 plus 3 over 4 plus 5, which is 7 over 9. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle. What is the meaning of the following? An eye for an eye. How good is that one? Here are the answers to the quick quiz, and the video is at your disposal.